Thanks. So hi all, this is my first speaking slot at an event, so excuse any nerves. I'm going to give it a go and see what goes wrong. So share first of all a little bit about Redington, where we've come from. You won't have heard the name around these parts very much. So I'm the new lead in our Bristol office. We've started from a firm back in 2006 with the mission to provide unbiased advice to pension schemes to provide financial security to its members, trying to close that pension deficit. We've evolved that into a purpose to make 100 million people financially secure, and so that's really the purpose behind the company, alongside its areas in finance and tech. But it's clear, in order to achieve a target like 100 million people, that technology has to be a key part of that, and that's why we're in Bristol, I guess. So over the last 13 years, we started off in London just to support our technology, to support our existing business, providing internal tools to try and help deliver that pension advice. Over the last year, we've scaled up. We've opened an office in Beijing, as we've had a product opportunity there, and we've also opened our Bristol office. Some of our team is here tonight. And we've come to Bristol to try and find those talented people that really relate to our purpose and relate to what Redington's culture is all about. We've opened an office. We're in Runway East, which I think so are some of BJSS and some of many of you already. We've started engaging with local charities. Redington Acorns is a kind of initiative to try and reach out to local charities and help them flourish, whether it be through our skills within the business or through our time just as members of society, as well as launching our own Meetup that I don't want to plug too much, but fintech with a social purpose. I'm not in any way competing with the other ones that are here. And we've also found a great group of people that have got a variety of random pictures. So that's enough about Redington. That's where we've come from. That's where I've come from anyway. So what problem are we trying to solve? What are we trying to talk through tonight? What I'd like to share is one of the key development decisions we've made at Redington, where it's come from, but also some of the benefits and drawbacks associated with it. When you're starting a tech function in financial services, it's clear that getting to grips with the domain terminology and the business domain is really vital. Especially important in financial services, where misunderstandings in domain terminology, like points, basis points, would have a direct financial implication. And whilst in every organisation that I've worked at, we're doing this to some level, whether that be during the discovery or the design phase with BAs or product owners and that sort of thing, that understanding of the domain terminology doesn't always end up in development, doesn't always end up in the software we produce. We often end up with requirements that obfuscate those scenarios and processes, and we end up with software that is delivering what the requirements say but not what the users want. And so what we want to do is to try and understand what the underlying problems are, not just trying to provide a solution, but understand what problem, what processes are we trying to challenge. And it can be hard, but it is definitely beneficial. And how do we do that? How do we keep doing that? And I'm not talking about keep drinking alcohol, although that helps as well. And so this is where we look at domain-driven or event-driven design, or at least that's what we've done at Redington. We take that use case and scenario-driven view of the world throughout our entire tech stack. It's not just our BAs or our product owners that are trying to understand the domain, but every part of development needs to too. And that gives us really clear discussions that are precise and relate to both the code and the domain simultaneously, harping back to DDD, ubiquitous language with Eric Evans. Feels like decades ago. It is decades ago. Also means that the software we build and the code we produce is separated naturally into the different business areas, and it's cleaner and more domain specific. And then the tests we produce are also validating those use cases, not just validating APIs or interface interrogation. And so what does that look like? Well, it means that our design process isn't trying to map to a set of requirements, although requirements play a part obviously, but it's mapping to those scenarios and processes that users follow. And we do this through modeling events and commands that users need to apply, a series of events, each of which has some associated data. And then the state, the kind of current state of the view, that relational data model that we have traditionally is derived from that series of events, event sourcing. And by having our software more closely model that stream of events, that processes and scenarios that the users follow, we actually feel like we're delivering solutions that the users really relate to rather than just that they think that they want. And it's not a new concept. So you've probably heard talks, watched videos about event sourcing in the past, and people talk about the great things about it, and I'll share some of the drawbacks we've faced by actually implementing it in real life SaaS products. But it's something that you have in development, in technology, and in outside in different parts of the world. So taking SQL Server, for example, that's built on an event sourcing model, or at least you could relate it to it. We don't apply, when we're applying an insert, an update, or an add column to our database, that's getting written to a transaction log. That's not immediately applying to your tables. Once that transaction log is written to, it's then applied to the tables. It's kind of projected, if you will, onto the tables and onto your database structure. If you have some kind of network failure and the database goes down, it's not the tables that are the truth, it's that transaction log that we go back to try and bring our database back up to speed. And similarly with Git, we don't have a current state. If you look at a repository, you can't immediately look at it and go, this is what the latest version of the code is. That is derived by applying every commit, every event that's ever been applied to that repo, and building the current state into a workspace or similar. And it sits outside of technology too, so lawyers do the same thing. We draft a contract, send it out for review, make addendums. The latest contract isn't a thing that exists. It's built up from all of those drafts and addendums that have been combined together. And similarly in banking, if you go and deposit £10 into your bank account, that doesn't immediately appear on a balances table. They don't just take your current balance and add 10 to it. They add 10 into a list of transactions that have ever been applied to your bank account, and then derive your balance from it. So it's not a new concept, and it's not a tech concept at its core. And this banking demo is what I'd like to share a little bit tonight, if the gods are with us. So I'll share first what the events look like. So the key part of event sourcing is defining what interactions the users are going to have. So I've modelled 4 fairly basic events: a deposit, a withdrawal, a transfer, and a payment. Each relates to account, or in the case of transfer, multiple. And they've got some associated data. And the data is specific to those events. So for example, taking the amount on deposit and withdrawal, there's no sign on that. Deposit, you deposit £10, you withdraw £10. There's no minus 10 in this scenario. So the data really truly relates what the user is doing. And talking about the projections, and this is where the demo will go. The concept is take your event, take the current state of the world, so take your current balance, and project it into a new balance. So if there is an existing balance, that is, so balance version 1, add another deposit, balance version 2, make a withdrawal, balance version 3. Fairly simple concept. And what I've used for the demo, not trying to plug it in any way, it's free, it's just quick and easy to get up and running, is eventstore.org, founded by Greg Young, who was kind of the first person to really talk about event sourcing. I think it was back in 2003. Wish me luck. Cool. So setting up an event store, pretty simple. What's the font size like? Would you like a zoom? Let's just, I thought it, thank you. I don't have a, maybe that's a bit bigger. So setting up an event store, fairly simple command, and we've got something up and running, which we can then browse to, and has got a core set of queues, streams, projections that are already running, but they're built into the system. And we can very simply create a new stream. We can apply some events, so size-wise looks okay. So I've got a handful of example events, so a very simple deposit here. I'm depositing £1,000 into my account. I wish it was that simple. Woo, I'm rich. Well, not really, but a little bit richer. And so I can now go back to my stream. I've got a stream of transactions, and this is the start for. Yeah, sure. Scroll isn't helping me. Cool. So I've got a stream of transactions. Our data's captured against it. But obviously this is hard to interrogate. If I want to look at the current balance, I haven't got anything. If I add another event into this stream, another deposit, let's say I just do the same thing again, I then can have a look at my stream, but I don't really have an understanding of what's in my account. I don't know anything from it. But that's okay. That's the starting point. So we've got our series of events, and we can now work out what's going on. So this is where projections come into the system. So I've built a fairly simple projection, which is very easy to set up. So let's call it balance. The idea is you build it from a stream. It's initialized with some form of initial state. So I've said that I've got no initial state. And deposit, when that event is applied, I'm taking the current account, if there is one, and adding on the amount of the deposit. I can run that continuously, and now I've got £2,000 in my balance. It's running that, and so if I apply another event into the stream, if I make the same another event, so for example, I've got another one here which is depositing into some other person's account. Adam, lucky guy. He's depositing only £50. Oh, that was the withdrawal, excuse me. £2,000, that's more like it. Add that into the stream, and if I pin that over here, we can look at our projections. Got a balance projection, and now we've got 2 accounts in the system with some money. And as we apply events, these will continually update. Well, or will they? So if I now make a withdrawal from Adam's account, back over here, add another event. Let's hope I've spelt it right. Oh, well, our account's still set at 2,000. We've only dealt with the deposit event. So this is extending our projection. Our initial one dealt with deposits. We add another function in for each one. So I've built a version 2, slightly more complicated version that we can edit over here. We need to reset that so that we replay all of the old events and go back from the beginning of time. And we now derive a new set of state. And actually what I've done is I've extended it so that it both captures the balance, but also starts summing up some other numbers. So I've got total deposits or total deposits and withdrawals. And this is where you can take projections. But again, if I start adding some more events, so let's say I add a payment into the system, we haven't dealt with that. And so we're going to see, again, that the account is representing the wrong amount for the user. He spent a large amount of money at Amazon. And we're not capturing that. So our balance is out of date again. And this is where we keep extending our projection until we're covering all of the events that we need to accommodate. So my balance is version 3. Goes back to the simple model of just having a balance, but now has a function for each of the events that can happen on the system, with transfer being a little bit special because it's dealing with both the to and the from account. And that's on the assumption that everyone's balance is at the same bank account. And so resetting that, we've now dealt with the deposit, withdrawal and the payment. And for example, if I were to now add a transfer into the system, transferring from Adam to Tom's account, we should see that affect both of those numbers in here, transferring £250. Very simply, we're seeing the ability to quickly set up a stream, quickly set up some projections, and these are also, this data stream here is already available on an API that we can integrate with. We can apply events, we can get the data out of it, and we can extend that projection further. And in fact, balance is one example. Transaction report, for example, that might be something that will be useful to produce at the back of a system, so we can add another projection for that. I've sort of hard-coded the parameters of this transaction report. So I've actually defined them in the initial state to say that I want to pull out the data for my account for March, but we could parameterize this transaction report. And in this case, I'm doing a one-time only mode. So I don't need this data permanently kept up to date. I just want to grab the transaction report. I'm looking at historic data. It's unlikely to it's unlikely to change now that we've gone past the 1st of April. And we can see a list of the transactions applied to my account, a deposit, and then a transfer from Adam. And that's dealt with by, for each of those events again, pushing something onto our transactions collection. Capturing the data that we want, mapping. For example here, I'm choosing to add a sign to our withdrawal because that feels meaningful in our transaction report, but doesn't elsewhere in the system. I think that's it on the demo. Nothing failed too badly. I'm just trying to switch back to the presentation. Excuse me. It wasn't the demo that went wrong, it's just PowerPoint. There we go, cool. So what else? What are the other benefits? That seems fairly simple. It feels quite an easy thing to get up and running with. What other benefits do we get? Why would we choose that over relational databases, say, or any other form? In my opinion, the biggest benefit is the data that we have available. We've made data, the history of the system, the core of our system. So if we need to go back and look at what's happened, we don't have to rely on having built an audit history into our relational database. We haven't got to rely on every CRUD performing an audit or adding an audit to an audit table or anything like that. We've got that data built into the system. So if somebody hacks production, well, either it ends up in the history or it disappears the next day. And that's one of the great benefits of it. You've got that data that you can trust, and when somebody comes along and says, why are these balances looking out of date? Well, we can see where the data's come from. Yes, we can identify the bug, and if we need to fix it, well, we can replay that system. And this brings back another problem, the DB upgrade. Well, we don't really have them. Our DB upgrades are kind of code upgrades written in projections. Yes, we still have the problem that we could deploy a new version of the system and then there's something not working. We could have a projection that's causing our balance to be in negative numbers. That's not helpful. But the nice thing is that when we want to try and fix that problem, all we have to do is fix the projection, replay the events, and we're now back in a good state. In fact, the biggest concern with me for a DB upgrade is you deploy a release, it all goes well, and then a week later it starts failing. And you've got to roll back. Well, you can't roll back all the data that you've got in the new columns, in the new tables. So then you've got to be a cowboy or a fireman. And they're the two hats I don't like wearing. You've either got to try and hack production and get your relational database to have the right values in it and deal with the fallout later, or you've got to firefight, keep the users happy, try and make sure that they're not breaking the system further while you try and fix the problem, and then rectify it. Well, event sourcing gives us that other option. We can be that cool developer that sits in a coffee shop drinking coffee. In fact, exactly what you were talking about doing earlier. And by having that option, you can fix the problem. We can then go back to a week ago when we made the deployment. We can replay the events, and we've now got a correct balance. We're happy and the system's working. It's that added security that I don't feel like you get if history is not at the core of your system. So what's the downside? Sounds like a great idea, sounds like some good benefits, but what are the problems that we're going to face? Well, the first hurdle to overcome is eventual consistency. We probably have wanted or idealized using or accepting eventual consistency because we want to have better fault tolerance. We want to accept that when the system goes down, it can come back up safely. If part of it goes down, we can still bring it back up safely. And so arguably it's a blessing in disguise, but we still have bugs that are raised when a user says, well, I've just played a check into my account and it's not appearing on my phone. You're always going to have that problem. There's always going to be the confused grandma with two cats. It's just something we have to come to terms with. And I think, to be honest, most of us are coming to terms with that already as we move to distributed and microservice-based architectures. Did you want that slide specifically in a picture, Chris? I do. Actually, there's the other problem is that your data model mistakes live on forever. With a relational database, you get the column name wrong, you get your data structure wrong. If you do a DB upgrade, yes, you might be a cowboy or a fireman for a bit, but ultimately that history goes. In event sourcing, that mistake lives on forever. You are always Green Lantern and reminded that you were Green Lantern, and that's not ideal. It's okay, but every projection that you write, every model of that event, you've got to cope with the fact that 10 years ago, you got the structure wrong. Some event sourcing solutions support things like event migrations so that you can transform odd events, but I think playing with history is dangerous. It's also a change of mindset. So we've, for years, developed CRUD systems. It's been our go-to. And moving to event streams or event sourcing solutions doesn't mean just a stream of create, update and delete events. In fact, it means completely the opposite. It means trying to model what user scenarios are happening, what operations users are performing, and trying to represent that in the core of our system. And that stream of events is a difficult thing to get used to, but it's actually how we think as humans. When we're going to catch up with an old friend, we don't go to the coffee shop and say, I've got 2 cats, a house and a green car. You actually say, well, since last time we caught up, I bought a new car. I've crashed my car, and then I bought another new car. We build up a mental picture. We kind of project those events into, oh yeah, so he's now got 2 cats, a house and a green car. But we've gained some extra information in the process. We've gained the fact that they've had a car crash, and that's a piece of information you don't get by comparing the state. And there's a bunch of other challenges too. So if we talk about set validation, we don't have records in a database, so how do we apply a unique constraint in the traditional way? We can't just go in and hack the production database, because as I said, tomorrow when the events replay, we get a fresh state built from the history. So the only way to hack is to, well, change the history, or to add a new thing onto the history. You start to build compensatory events rather than trying to tweak away any problems. And you also get things like, well, having to share why we're doing it. When I talk to my product owner and say, no, we don't have just create, read, update operations. We're trying to model the user scenarios. It's that explanation fatigue. It's not something that everyone's used or everyone's aware of. And like with any solution, this added complexity doesn't have to be everywhere. We can choose to just apply it to the domains that it makes sense to. We can have relational databases for those that it doesn't. We can have a file-based system for the other areas that don't. So to conclude, I might be a bit ahead of time actually. There's a bunch of great benefits. It's quick to set up. We get a lot of confidence by the fact that we're building against the domain that users see. We have our code and conversations are really clear. And there's a handful of challenges as well. And it's not going to be for everyone. At Redington, we think the benefits outweigh the challenges, but we're 2 years into it. So who knows? We could find in 10 years' time that it's impossible to manage that 5 million events. Although I think we'll be able to afford the data costs because that's always getting cheaper. So I guess the key takeaway is you've got to pick the right solution for you. You've got to find the right solution as ever. And if that is event sourcing, great, we're enjoying it. If it's relational databases, then there's nothing wrong with that too. Or if it's a paper-based system, that's fine as well. Any questions?
Would it be allowed to, say, collapse all your history up to a certain point into a state, call out an ad, and then cut your history off there and start again?
Yeah, so it's actually
Could you repeat the question?
Yeah, sure. So the question was, is it allowed, is it supported to collapse your history into, and maybe call it an ad, and then play on from there? And actually that concept exists. So the concept of snapshots exists within event sourcing, much like a database snapshot actually, where you go, right, I don't want to keep that transaction lock forever, so I'm just going to take a snapshot, munge all of that together, and then that is my starting point for ongoing events. And that's, yeah, perfectly allowed and in fact recommended when you start dealing with 5 million events. Our production replay of events takes 45 minutes and we haven't started introducing snapshots yet. 45 minutes feels okay. If the system goes down, that's fine, but we need to. That's the next step for us.
In a lot of like event kind of systems, a lot of the events like commits and git depend on the previous commit.
Mm-hmm.
What if I send you like a GDPR
Yeah, it's actually a really valid challenge. So it's one of the challenges we face with event sourcing, but also with any system that's maintaining that history. You've got to delete an audit. So if you have an audit table in a relational database, that's trivial. Event migrations is an example of how you can use that. Yes, changing history is dangerous, but if we need to go and transform those events and obfuscate them, we can do that. There are other solutions. So you can argue that if you rather than migrating events, you can have transformers that sit in front of your event store. So as you're reading them out of the event store, you can only read the ones that you're allowed to see, so you can have sort of security on it. But whether that classifies as meeting the GDPR concerns, it's not. You look at something like blockchain, that's arguably an example of event sourcing. In fact, it's not arguably, it is an example of event sourcing. That's even harder because changing the history in that is impossible. You can't go and alter the event stream. So how does a solution that's built on that alter it? Don't know. Our plan so far is to use event migrations when that day comes, but we need to keep 7 years of history and we're 2 years in, so we've got 5 years to worry about it.
Have you had to deal with a change in your schema of your JSON objects that you're storing? Have you had to deal with that in production yet?
Yeah, so we've had, we represent, one of the models is representing entities. So we have a system where you can build or define your own entities in like a configuration file. And so actually the model changes on those entities. It means that we have to build slightly more dynamic projections. But we've often got the grouping wrong, so you get the hierarchy wrong. And what you then have to do is deal with old versions of your projections. And I think adding a version number onto your schema of your events really helps with that, because then you can essentially add a switch statement into your projection that says, if I'm looking at a version 1 code, this is how I'm going to deal with it. If I'm version 2, and then you're just looking at your latest code. The downside is that every version of projection that you've had to deal with, you've got in your code, and you've got it in your latest code. You don't just have it in the old Git repo. So it's tricky. It's not a type and a version number. In fact, I think I think in event store, it's over here. There's metadata section where you can add version and or a naming for the schema if that's the way you want to do it. One more.
Might be a stupid question, but how does domain-driven design relate to event sourcing?
So, I guess taking a step back from event sourcing, when you're arriving at trying to understand the business domain, those business domains are what derive your commands. So domain-driven design talks about trying to define ubiquitous language for each of your domains and key concepts that are shared with you and the business, and those terms. And those terms are what define what our events are. So when users are talking about, I want to make a withdrawal to my account, that is us discussing the domain with the user and then us defining the event from it. And we have actually 4 or 5 domains within our system that represent different areas of not of the business, but of like the user base and how they use the system. So we might have like a domain talking about the notes area of the system and how they interact with that versus other areas of entities or something like that. Is that go for it? Sure.
I see a lot of people using Kafka for event sourcing. What do you guys use, and what do you recommend?
I wouldn't recommend any. I think that you've got to find one that suits you. So asking for recommendation of what people use. We use on some of our legacy products, Get Event Store. It's free to set up, but the projection system is relatively limited in that, well, you can see I'm building everything in JavaScript, and that's some form of limitation. Whether that's enough for what you're trying to build, that's one answer. We use something called MartinDB, which is like a CQRS framework. Well, we've got a CQRS framework sat on top of MartinDB, and that does near enough everything we want it to do. Projections are built in C#, so you have a lot more scope to write more code or more complex code. But we're starting to hit problems with that where it's not meeting all of our needs. There's a bunch out there. In fact, when Greg Young talks about, so the kind of the founder of event sourcing talks about what solution to use, he will push this because this is the one he's built, but he says it's got failings and every one of them's got failings. You've got to iron out what it is that you're trying to solve with those problems. It's kind of the same as everything. That's it. Oh, go ahead.
What's your strategy for taking snapshots
We don't have one yet. So we're at the point where 45 minutes is acceptable for us to replay all of our events. So we can replay all of our 45,000 events, 45 million events into a fresh set of projected objects in 45 minutes. That's fine. When we get to snapshots, this is probably a challenge for us over the next year. We need to find a way to bring that time consistently within that 45-minute mark or whatever it is that we define for our SLAs.
So, presumably part of the way that you handle constraints is a bit about how you don't have unique constraints, keys and tables and things.
Yeah.
Presumably it is feasible for people to produce events which are illegal or invalid. What happens if you have a sort of section of your history that you deem to have been made sort of in error or made because sufficient constraints were not in place to prevent those events happening? How do you deal with sort of corrupt section of history?
So I guess yeah. So how do you deal with the corrupt section of history? If people are able to break constraints and get events into the system that are invalid, how do you deal with that? How do you accommodate that? So one way is that we obviously are adding constraints, what I would call like almost racy constraints prior to the event being applied. So trying to catch people before they perform an event that's invalid. You've got constraints that happen afterwards. So if we notice that a user's subscribed to our meetup with the same email address again, then we need to add a compensatory event. The problem is that in your projections, if you've got to deal with those events and then the compensatory events in every one of your projections. So where you've got validation that can be broken, your projection has to cope with the fact that something invalid can happen followed by something valid. So it's the problem with things getting in is that they hurt your history. They hurt in your code forever, in your projections forever.
But it's potentially the case that a previous event, if treated as valid, would make a later event. So, say for example, if you have a bank account
Yeah.
and you make a transaction that you shouldn't have been allowed to make, because you wouldn't have necessary balance, and then you later try to make another transaction, the fact that your prior transaction, put you below zero, as it were,
Yeah.
means that later events which were dependent on that event, such as you've transferred to another person, then they transfer to another person, etc.
Yeah, so the example here is if you take some money out of your account, you haven't got enough money in your account, but the event ends up on the event stream, that takes you into a negative number. If then another event applies, how do you make sure that, so let's say that you start off on £250, you try and make a withdrawal for 300, that goes into your event stream, you're now at minus 50. The next day, that should have been rejected. The next day you try and take out £200, that should be allowed because the 300 should have been rejected, is kind of what you're describing. Well, what should happen in that scenario is that you're catching that event after it's been applied, granted, and applying a compensatory event to it. So you're applying a plus 300 back to the account to say transaction rejected. So you're then, by the time that something else is happening, you're able to withdraw that £200. So it's about noticing when constraints are broken and then applying another event to the stream to compensate for it. But this should be the race condition edge case, because you should still have the validation before it happens as well, trying to say, well, I'm going to check to see if your current balance allows you to do this. Obviously, two events could be coming in at the same time, and then dealing with it afterwards if it does. Is that? Yeah. Cool. That's it. Thank you.